Okay, so welcome back. We're ready for section 7 of chapter 5. We're going to start off with you guys solving some exponential equations with the variables and the exponents. So 3 to what power equals 9? Well, that's relatively simple. It's 2, and that's the answer. 4 to what power equals 64? Hopefully that's relatively simple. It's 3. 4 to the third power is 64. 5 to what power is equal to 1 over 125? Well, think of it as 5 to what power equals 125, in which case 3 is the answer. But since the 125 is in the denominator, negative 3 is the answer. Okay? But this one's not so easy. 2 to what power equals 11? Well, that's a question mark. We're not real sure. We know that it's somewhere between 3 and 4. Do you agree? Because 2 to the third power is 8, and 2 to the fourth power is 16. Does that make sense? That means 2 to the third power is somewhere smaller than 11, and 2 to the fourth power is somewhere greater than 11. 8 is less than 11, which is less than 16. So the whole point of that is to say that we know the answer somewhere between 3 and 4. 3 and 4. We just don't know exactly what it is. Well, today, I'm going to show you a couple ways to figure out exactly what it is. And here it is. All right, if you have 2 to the x power equal to 11, and you want to solve for x, what you do is actually take the logarithm of both sides. Take the logarithm of the left side and the logarithm of the right side. Write that down. We took the log of both sides. Now what do you have? You have a little baby. Do you see him? You can make him a big baby. So this is x log 2 equals the log of 11. And now check it out. The log of 2 is just some number. It's the exponent that says, 10 to what power equals 2. You can divide both sides by the log of 2. So it's the log of 11 divided by the log of 2. And then you would just type that in your calculator to figure out what the answer is. So let's do that. Alright, so here's my calculator. I'm going to type the log of 11 divided by the log of 2. That's what it looks like right there. And just hit enter. And boom, that's our answer, about 3.46. And that makes sense because we said that we thought the answer would be somewhere between 3 and 4. Let's write that out. X is about 3.46. That means 2 to the 3.46 power is about 11. Okay. Now, there's another way you could have done that one, and that's this. All right, you could have said, all right, 2 to the x power equals 11. You could have rewritten it in logarithmic form. So it's the log in base 2 of 11 equals x. And now you get to use a shortcut. It's a shortcut that I've waited till now to show you. And you can say that x is equal to the log of the big number, which is 11, divided by the log of the little number, which is 2. See, up until now, you couldn't do this in your calculator, right? Because your calculator only knows base 10. Base 2, your calculator says, hey, dude, I don't know how to do that. But now you can outsmart the calculator by using something called the change of base formula. This, when you type it in, it's about 3.46. Same answer we got last time. Now, the change of base formula says the following. It says if you take the log in any base, not just base 10, but any base, base A, the log in base B of A, it's equal to the log of the big A over the log of the little b. And now you can use your calculator anytime you want. It's the log of the big number divided by the log of the little number. How cool is that? Use your calculator anytime you want. So let's try a couple. So here we have 5 to the what power equals x? Well, first off, we know that the answer is somewhere between 1 and 2, because 5 to the first is 5 and 5 to the second is 25. It's probably closer to 1. So this is what I want you to do. Take that little baby, make it a big baby. But when you do that, you have to take a log on both sides. Take a log on both sides. Now divide both sides by the log of 5. So I have the log of 8 divided by the log of 5. And you just type that into your calculator, because now everything's in base 10. Answer, about 1.292. And you can check that on your calculator. It'll work. Alright, try this one. Log in base 2 of 7 equals x. Well, this one, x is already by itself. That's awesome. You have the log in base 2 of 7. You can use the change of base formula. You don't like base 2, but you like base 10. Well, make this a base 10 problem. Well, that's just the same thing as the log of the big guy over the log of the little guy. Love the change of base formula. Makes life so much easier. Type that in. Answer should be between what, 2 and 3? Yeah, it's about 2.807. Check that on your calculator. Okay, try the next one. Take the little baby, throw it out front, but to do that, what do you have to do? You have to take a log of both sides, which we've done, and then just solve for x. So x is equal to the log of 32 divided by the log of 5. Again, the answer should be somewhere between 2 and 3, because 5 squared is 25, and 5 to the third power is 125. That answer, about 2.153. Cool. Okay, these are a little bit trickier, but they're not bad at all. Okay, what I would do here is take this little baby, make him a big baby, but to do that, what do you have to do? You have to take a logarithm of both sides. And now you would divide by what? Would you divide by log 1.1 or would you divide by negative log 1.1? Well, it doesn't matter. If you want to just do it one step at a time, do the log of 2 divided by the log of 1.1. So negative x is about equal to, in your calculator, 7.273. But you don't want negative x, you want positive x. So x actually equals about 7.273. Sweet. Okay, try letter D. Do the same thing, guys. Here we go. We've got, let's see here. Oh, wait a minute. In letter D, we don't even have to use big baby, little baby. I'm sorry. Remember, old tricks still work. I don't want to go away from everything we've learned this entire chapter. This really says 3 to the x equals 9 is 3 squared, and the cube root of 3 is 3 to the 1/3. Now, can you say bye-bye threes? Well, not yet. You need 1 3 on the left and 1 3 on the right. Side by side means add them, add them. And 2 plus 1/3 is really 6/3 plus 1/3. That's 7/3. Now you can say bye-bye threes, so x is exactly 7/3. You could have done this to change a base way too. Same answer. All right, now here we go, letter E. Now this one's a little bit different because instead of the regular log, you're not going to use that because this one involves an E. So instead, are you going to log this one or are you going to natural log this one? I spelled that wrong. Boy, Mr. Williams, you must be a bad speller if you can't spell LN, right? So log it or natural log it. My high school calculus teacher used to call it the lawn. Log it or lawn it. Well, you're going to take a natural log this time. So you're going to throw the x out front like you did. But instead of taking a log, you're going to take the natural log of the left side and the natural log of the right side. Well, look who just showed up to the party, folks. Do you see him? Do you see who just showed up? Lenny just showed up. Lenny, get out of here. Why does Lenny go away? Because Lenny just equals 1, doesn't he? All right, and x times 1, that's just x. So this is the natural log of 0.05. Type in natural log of 0.05 to your calculator. It better be a negative number, and see what you get. It's about negative 2.996. Sweet. So when you have a problem that involves an e, don't just use the regular log, use the natural log. Okay, so before I let you go, we're going to do some story problems from this section. Application problems. So a radioactive substance has a half-life of 1.4 years. In part A, if there are 10 milligrams right now, initially, how much would you have left in 7 years? How much would you have left in 7 years? Well, folks, this one shouldn't be too hard. It loses half of its amount every 1.4 years. So a formula should be popping into your head, and it's this formula. We've used him before. A of t equals the initial amount times b to the t over k power. Hopefully he's popping into your head. Okay, what's a now? What's a not? What is it starting with? It's starting, let's label everything. The initial amount is 10. What's happening to the initial amount? Is it doubling or being cut in half? B is a half. That's what's happening to it. How long does it take for B to happen? That's K. How long does it take for B to happen? Oh, it takes 1.4 years. That's what it said. And finally, what's the amount of time that we're interested in? The amount of time we're interested in? 7 years. Okay, we got everything. So our initial amount is 10 milligrams. What's happening to the initial amount? It's being cut in half. How long does it take to happen? Oh, 1.4 years. That's a T up there. So that's our formula, but we're interested in the amount of substance after 7 years. So let's plug it in. I've got 7 divided by 1.4. Now I'll just type that into my calculator. So let's get calculator out and type it in. There it is. Make sure you put it in parentheses. 10 times 0.5 raised to the 7 divided by 1.4 power equals 0.3125 milligrams of the substance. That's what you have left. So I'm not even going to put squiggly here. I'm going to put exactly 0.3125 milligrams. That's what you have left after 7 years. Okay, so the last one was pretty straightforward because you had everything that you needed, and you didn't have to take a logarithm or do anything like that on both sides. Now this time, the radioactive substance has a half-life of 1.4 years. But how long does it take to decay to 4 milligrams? Alright, so let's write our formula again. The amount after a given time is equal to the initial amount times whatever is happening to the initial amount. I put 1/2 there. I should just put B. I'm getting ahead of myself. Raised to the T over K power. Now what do we know here? We know it has a half-life of 1.4. That means the initial amount's being cut in half. How long does it take to happen? 1.4 years. What's the initial amount? What's the initial amount? Well, we want it to decay to 4 milligrams. We want it to decay to 4 milligrams. Do we remember the initial amount? I think they said that the initial amount was 10 in the last example. So that's what we'll go with. And what's our new amount? What's our new amount? What do we want to end with? Well, that's here. That's 4. How long does it take to happen? Well, that's what we're trying to figure out. So fill in everything we know. The amount we want to end with is 4. The amount we started with was 10 milligrams. What's it doing? It's being cut in half. How long does it take to happen? 1.4 years. How much time does this take to happen? We don't know. Let's solve it. Let's figure out. We got to solve for t. So what I would do is get rid of the 10 first by dividing by it. Is that fine with you guys? So that actually says 0.4 equals 1/2 to the t over 1.4 power. Now the problem is t is in the exponent. I don't want t in the exponent. I want it in the base so that I can solve for it. So actually, we're going to take a log of both sides, and you hopefully know where I'm going with this. We're going to use the big baby, little baby rule. We're going to use the power rule. 1.4. 1.4 is what that's supposed to say, 1.4. So take this t over 1.4 and throw it where? Throw it out front. Now it's a big baby, so it's t over 1.4 log 1/2. This side is log of 0.4. And now just solve for t. I would divide both sides by the log of 1/2. Divide this side by the log of 1/2. Those are gone. And now we're almost done. To get t by itself, you need to take the left side, log 0.4, divided by the log of 1/2. And what do you need to multiply it by? You need to get rid of that 1.4, so multiply the whole thing by 1.4. So type this into your calculator. Type log 0.4 divided by log 0.5, same thing as 1/2, and then hit enter, and take that times 1.4. And you'll get about 1.85 what? This is time, and time was in years. So put years right there, 1.85 years. So that one took a little bit more work. We had to take a log of both sides over here. Why did we have to do this? Because our variable was in the exponent. We had to use the big baby, little baby rule, or the power law. Okay, now let's use a different formula that we haven't used in a while. An investment at 6% annual interest compounded daily. How long does it take to triple? So since we're talking about money, we're going to use this formula. A of t equals the original amount, 1 plus the rate, but here the rate must be divided by the number of times you compounded, raised to the nt power. Number of times you compound it over the course of the length that you're interested in. So what's n? Daily means the number of times it's compounded is 360. What's r? Well, that's 0.06. What's the initial amount? How much do we start with? And furthermore, how much do we end up with? Well, we don't know. All it says is it's some investment, and they want to know how long it takes to triple. That's it. Well, that means you can invest any amount you want. You guys get to pick this guy right here. What do you want to start with? I always say it's easiest just to start with, say, $1. $1. And then we want to know how long it takes to triple. So what's that? Well, what's $1 tripled? Well, it's just $3. There we go. We want to know how long it takes $1 to turn into $3 if it's compounded at 6% interest, done so daily. Done so daily. So 360. And we don't know t. T is the question mark. How many years, or how many years does that take to happen? How many years does that take to happen? Or whatever time is in this case. Well, let's just solve this. Well, this one really doesn't matter. I'm going to clean up the parentheses in there. That really says 1 plus. In your calculators, type 0.06 divided by 360. And you get 0.000167. Still raised to the 360t power. So this really says 3 equals 1.000167 raised to the 360t power. Now, where's the t at, folks? The t is in the exponent. I don't want it in the exponent, so what do I got to do? I got to take a log of both sides. He is a little baby. Make him a big baby. And take a log of whatever the base was. Now, you just got to get t by itself. You just got to get t by itself. So t is equal to, you have to take the log of 3 and divide it by what? Well, you have to first divide it by the 360, and you also must divide it by the log of 1.000167. You got to divide it by both, and that will give you your answer. That will give you your answer. So in case you're interested, that's what it looks like on the calculator. Log 3 divided by 360 log 1.000167. And if you hit enter, right there, it takes about 18.28 years or so. 18.28 years. Get that out of here. So 18.28 years for $1 to turn into $3. Now, that seems like a long time, but think about if it was $1 million. Well, after 18 years, it's turned into $3 million. That's a pretty good deal. All right. Well, I think that's all I'm going to show you for part 1. Hope you had a good time, and I'll catch you later.